The nomenclature of aromatic compounds, presented by Muhammad Ibadur Rahman and Azmirul Nazril. A monosubstituted benzene has the formula of C6H5G, where the G is the atom or group of atoms that has replaced a single hydrogen atom. To name these compounds, benzene is used as the parent name, and the substituent is added as a prefix. A benzene ring that has a chlorine atom, Cl, substituting a hydrogen atom will be named chlorobenzene. If it were instead an ethyl group to be the substituent, the compound is named ethylbenzene. Sometimes the substituents give the monosubstituted benzene a special name. Toluene is a benzene ring with a methyl group, CH3, replacing a hydrogen atom. As another example, a hydrogen atom replaced by a hydroxyl group, OH, would form a phenol. The di in disubstituted means two, thus two groups. Three isomers can be formed when two substituents replace the hydrogen atoms. Ortho, meta, and para prefixes are used to name the disubstituent benzenes according to the positions of said substituents. Ortho would mean position C1 and C2, meta would be C1 and C3, and para at C1 and C4. When naming, we keep in mind to use the lowest possible numbering to a carbon atom for these substituents and to follow the alphabetical order. But when it comes to monosubstituted benzenes with special names, the monosubstituted compound becomes the parent for the disubstituted compound. An example of a disubstituted compound would be 1,2-dibromobenzene. We see that bromine atoms are attached to C1 and C2. Because of that, the 1,2 in its name can be replaced with the prefix ortho, forming ortho-dibromobenzene. As the names suggest, tri- and polysubstituted benzenes have three or more substituents. Like naming the disubstituted benzenes previously, these are named where the substituents have the lowest possible numbering to a carbon atom and follows the alphabetical order. And again, if the substituents give it a special name, it becomes the parent, and the parent group would start as C1. A clear example would be a benzene ring with a hydroxyl group at C1 and two methyl groups at C3 and C4. The hydroxyl is at C1 because it has granted the compound with a special name, which is phenol, and it has become the parent. The two methyl groups remain as substituents. Thus, its name is 3,4-dimethylphenol. In some cases, the benzene ring needs to be treated as a substituent. In these cases, the term phenyl is used to designate the presence of a C6H5 as a substituent. The method should be used when the benzene ring is a substituent of the root. For example, an amine with a benzene ring substituent is named phenylamine. Thanks for watching.